Welcome to day 4 of the challenge series. Today we will look at the business problems that would require you to apply joins to get the results. Joins are the fundamental building blocks in SQL. So before we jump to the problems, here is a quick overview about the joins. What is a join in SQL? In SQL, a join is a clause used to combine rows from two or more tables based on a related columns between them. In other words, it allows you to retrieve data that is spread across multiple tables and present it as a single unified result set. Now let us look at an example. So here if you see, we have two tables. One is a toy table and the other is a cat table. The toy table contains the toy ID as the primary key, the toy name and the cat ID as the foreign key. The cat table contains cat ID as the primary key. But what is a primary key and a foreign key? A primary key is a column or a combination of columns that uniquely identify rows in the table. In our case, the toy ID is the primary key in the toy table and the cat ID is the primary key in the cat table. So what is a foreign key then? A foreign key in SQL is a column or a set of columns in one table that establishes a link to the primary key or a unique key in another table. What it means is the cat ID is a foreign key because it is a primary key in the cat table and the cat table is linked with the toy table through the category ID. Now let us look at some basic types of joins. Each join returns a different set of results based on how matching and non-matching rows are handled. So the first is inner join. The inner join returns only the rows where there is a match in both the tables based on the join condition. If we look at it from the Venn diagram perspective, table A is represented with one circle and table B is represented with another circle. Now, when we apply inner join, we get only those columns which are common for both A and B. The syntax for writing any join is you select the columns that is required and then you give the first table and you apply the type of join and then you give the second table name and then you give a condition on which the join should be applied. Remember, the table which is to the left of join is the left table and the table name after the join is the right table. Though it is not as important for the inner join, but it is very important for left join and right join table. So if we look at our example, we selected all the columns from toy and we apply an inner join and join the table cat on the condition where the columns cat ID are common. So if you look at this table, we have the columns 1, 3, 4, which are common in both the table, and we get all the rows which are common for both the table based on the condition. So remember one more point. The join condition doesn't have to be an equality. It can be any condition you want. It only checks if the rows satisfy the given condition. So the next is natural join. The natural join returns only matching rows from the tables that are joined, but the common column appear only once. It is similar to the inner join. Here also the syntax remains same, only the keyword changes from inner to natural. Now we apply the same syntax to our example and we see that cat ID column is appearing only once. So the next is left join. Then left join returns all rows from the left table and the matching rows from the right table. It is also called as left outer join. When we look at our Venn diagram, all rows from table A will appear in the result and only the matching rows which matches the condition will appear from the right table B. The syntax remains the same, only the keyword changes. But remember here that the table name which appears before join is the left table and the table name which appears after join is the right table. So when we apply this in our case, we do the left join and join the table toy and cat on the cat ID. So in the result, if you see, the whole left table appears in the result and only those rows which matches the condition appears from the right table. In conditions where there is no match in the right table, null values are returned for the right tables column. So the next is right join. Conceptually, it is similar to left join. Right join returns all rows from the right table and the matching rows from the left table. If we look in our Venn diagram, when we apply the right join, we get all the rows from the right table, that is table B, and only those rows which matches the condition will get from table A, which is the left table. So when we apply the right join in our case, we see that we get the whole right table and only the matching rows from the left table. So if there is no match, or for rows where there is no match in the left table, null values are returned for the left tables column. So the next is full outer join. Full outer join returns all rows when there is a match in either the left or right table. We see in our Venn diagram that when we apply the full outer join, we get all the rows from table A as well as from table B. When we apply this in our case, we see the whole left table appears in the result and whole right table appears. And if no match exists in one table, null values are returned for that tables column. Okay, let us now move to our business problem. So imagine a branch manager in London wants to send promotional flyers to all customers in that city. We need to pull a clean address list to share with the marketing team. Now, looking at our ERD, we see that the addresses are stored in the address table and the city is stored in the city table. That means we will need to apply a join. So our approach will be, we start with the address table and we join it with the city table using the city ID. Both the address table and the city table contains the city ID, which will be our joining column, or which will be our common columns on which we will apply the condition. Then we will apply the filter where city is equal to London, and then we will select useful fields such as the address, the district, the postal code, and the city. Now let us see this in practice. Okay, so let us now look into both the address and the city table first. Select star from address. So here we are putting address in the square bracket because address is a SQL keyword, and as I mentioned in my last lecture, that any table name or any column name which has the same name as the SQL keyword, as a standard practice we put that table name or column name in an square bracket. Let us also select star from city and let us execute both the statements. So now here if you see, we have a city ID column in our address table and we have a city ID column in our city table. So this is the common column on which we will apply the join. So let us apply the join. So let us select all the columns for now from address. Here also we'll give the square bracket and we will give it an alias ID. Remember that SQL interprets the aliases without the as keyword. So we are just following that principle, and CTCI, and we join it on ad dot ct underscore id, the common column which is the city ID. So now here if you look, we did not apply the keyword inner because by default, if you just say join, it is inner join. However, for other joins you need to specify, but as a standard practice we also specify over here. And now let us execute this and see the result. So here if you see the two tables address and city are joined, and if we see the common column on which we are, which is joined, is the city ID. So all the matching rows are joined on the basis of the city ID column. So we have 603 records for this. Now let us apply the filter. So where ci dot city is equal to London. Let us now look at the record. So now we have two customers who live in the London city. Now we take only the names or only the columns that are required. So we take address as customer address, then we take the district as district only, and then we take the postal code. So we take the postal code as postal code, and we can also take the city. So city. Now here, when you apply joins, it is a standard practice that we give the table aliases before the column names, so that it is clear to the SQL server from which table are we requesting the columns. So we are requesting all this from the address table and this from the city table. So now if you see, we have applied all the aliases and given standard names. Let us execute this. So you see the customer address, their district, and their postal code with their city is the final output that we required. Okay, so here are today's tip. Whenever you apply joins, you give aliases to the tables that you join. It makes your queries shorter and more readable with the clarity and maintainability of the query. Also, always check the foreign key relationships before deciding your join path. The relationship from the ERD diagram helps you to strategize the approach that helps you to solve any SQL query problem.